Now, I want you to think about the room you are in right now, the bed beneath you, the texture of the sheets touching your skin, or the night light filtering through your window. To you, the world feels very familiar, very solid, and very reliable. For centuries, we have been convinced that we live in a universe built upon the grand and majestic laws of Isaac Newton, a world that runs like a clock. When you touch an object, you know it is there. When you throw a ball, you can calculate its trajectory with mathematical certainty. The moon, even when you aren't looking, continues to hang in the sky with its cold, silvery light. Classical physics whispered to us, the universe is a machine, and you are merely an observer standing outside of it. But now, I want you to set aside this false sense of security. Because we are going to scratch the surface of this solid-looking world with our fingernails. And dive beneath it, into that eerie, soft, and infinite sea of possibilities, the quantum realm. An acquaintance with quantum physics is, in essence, an art of unknowing. It is where the arrogant, all-explaining voice of science is replaced by a startled, wonder-filled, and perhaps slightly trembling whisper. Let us go back to the beginning of the 20th century. Physicists thought they had solved all the secrets of the universe. Light, heat, motion. Everything had been poured into formulas. However, when they peered into the tiny, dark, and deep heart of the atom, they realized something was going terribly wrong. Nature was refusing to obey our logic. What we called logic was merely a crude habit that applied only to the world of large objects. In the microcosmos, in the fundamental building blocks that make up your cells, your atoms, and your very soul, the rules changed entirely. There. Matter was not as hard as a rock, it was as volatile as a thought, as fluid as a melody. Imagine you are on a beach with a handful of sand. Classical physics tells you that a grain of sand is right there, with a specific weight and shape. But through quantum glasses, that grain begins to blur. It is no longer an object sitting at a single point, it is a cloud of probabilities. This is where the birth of the observer begins. You. The subject carrying consciousness, the moment you look at the universe is forced to give you an answer. Before you look, everything is in a state of slumber. Particles have not decided where to be. They are like ghosts, probability waves existing everywhere in the universe at once. Feel the weight of this thought. The atoms of the desk you are touching right now are not actually in a specific place when you aren't paying attention to them. They are a maybe. Entering the quantum world means giving up certainty, and surrendering to the peaceful embrace of uncertainty. Scientists were horrified when they first realized this. Even Einstein resisted this randomness, famously saying, "God does not play dice." But nature did not care about our beliefs. Particles were shaped by our gaze. This completely changes the human role in the cosmos. You are no longer just a spectator. You are the magician who brings things into existence by looking, turning possibilities into reality. The observer, your consciousness, is the anchor dropped into that vast sea of probability. When you look, the sea calms, and the waves turn into particles, into reality. Now, let us take your mind a little further back, to that great crisis of the physics world, the mathematical dead end known as the ultraviolet catastrophe. Imagine putting a piece of iron into a fire. First, it glows red, then orange, then yellow, and when it gets hot enough, it turns white. The laws of classical physics suggested that as this heat increased, the energy radiated should go toward infinity. Theoretically, turning on an oven shouldn't just cook your dinner, it should emit ultraviolet rays powerful enough to destroy the entire universe. But the real world wasn't like that. Something was wrong. Nature did not allow a continuous, uninterrupted flow of energy. Right here, in the cold winter days of 1900, Max Planck took the stage and, albeit reluctantly, began the greatest revolution of the modern world. Planck realized that energy was not continuous like a stream of water. Energy was actually in small, packaged, discrete units. He called these packets quanta. Imagine it like this: when you turn on a tap, you think the water flows continuously, but it is actually made of billions of tiny droplets. Light and heat are the same. The universe had a digital structure, it moved in specific steps. This discovery demolished all the scientific fortresses built up to that day. Because if energy came in packets, the universe was not a smooth surface, but a finely crafted mosaic. Think of the deep unease Planck felt while making this discovery. He was a conservative scientist, and he feared that what he found would fundamentally change the laws of physics. But the numbers did not lie. Nature progressed step by step. The room temperature you feel right now is actually billions of tiny energy packets colliding with your skin. Light may look like a continuous beam to you, but it is actually a rain of tiny light bullets. This idea of packets is the heart of quantum. Everything has a limit. Everything has a measure, and everything has a smallest unit. Now, focus your mind on a single beam of light filtering through a dark room. What is that light to you? A brightness, a wave, or an invisible cloud of dust floating in the void? Throughout history, the greatest minds chased this question. Newton believed light was made of particles fired like tiny bullets, he called them corpuscles. Others argued that light was a soft vibration spreading through the fabric of space, like waves in the ocean. Who was right? At the dawn of the 20th century, Albert Einstein, instead of ending this ancient debate, left us on the threshold of a much deeper and more chilling truth. Light was both. But at the same time, it was neither. Einstein's work on the photoelectric effect is one of the brightest torches of the quantum revolution. Imagine that we shine light on a metal plate. If light were only a wave, increasing the intensity or brightness of the light should be enough to knock electrons off the metal. Just like a giant wave dragging sand from the shore. But nature once again mocked our crude logic. Those tiny electrons on the metal didn't care how bright the light was, they looked at the color of the light, its energy. This was a very strange secret whispered to us by the universe. Light struck the surface of the metal in tiny energy packets called photons. If the incoming photon was strong enough, it could knock the electron loose. Increasing the brightness only increased the number of these tiny bullets, not their power. This discovery opened a massive hole in our perception of reality. The fact that light both spreads like a wave and strikes like a particle, destroyed our distinction between object and event. How can something be both a wave, a vibration that is everywhere, and a particle? A mass that is in a specific place. Herein lies the famous duality of quantum. Light is a mystical entity that changes shape depending on how we look at it. If you want to measure it like a wave, it answers you like a wave. If you want to catch it like a particle, it falls into your palm as one. This means the universe, like Play-Doh, reconstructs itself according to our questions. Now, let us move with heavy steps toward perhaps the most unsettling, confusing, yet fascinating experiment in the history of science, the double-slit experiment. Imagine an empty cinema hall in your mind. In front of the screen, there is a plate with two parallel vertical slits. Behind these slits is a detector screen. Now, let's imagine firing tiny marbles at these slits. The marbles will pass through either the right slit or the left. They create two vertical lines on the screen behind. Very logical, very classical, very familiar. Now, let's send water waves instead of marbles. The waves pass through both slits at the same time. These two new waves emerging from the slits meet each other. In some places they reinforce each other, and in others, they cancel each other out. They create a pattern consisting of many lines called an interference pattern behind the screen. This is a result of the wave nature of water. Everything is fine so far. However, when we bring things down to the quantum level, reality begins to distort like a miracle. Now let's fire electrons at these slits one by one. Electrons are particles, right? They are like little marbles. When we fire them one by one, we logically expect them to pass either from the right or from the left. But no. Even though we fire the electrons one by one, after a while, that famous interference pattern begins to form on the screen. This means, a single electron has passed through both slits at the same time. Even further, the electron has interacted with itself, acted like a wave, and lived both possibilities at the same time. This is superposition at the heart of quantum physics. A particle tries all paths in the universe simultaneously, until an observation is made. Physicists could not believe this. What is happening? They asked and placed a small detector, an observer, next to one of the slits. They wanted to see exactly which hole the electron passed through. And at that moment, the universe's strangest joke occurred. The moment we began to watch the electron, it stopped acting like a wave. Like a shy child, it noticed the presence of the detector and began to act like a normal marble. The interference pattern disappeared, leaving only two simple lines on the screen. That magical wave that passed through both holes when we weren't looking, turned into an ordinary particle passing through a single hole, the moment we looked. Now, I want you to focus your mind on a perfectly still lake on a windless night, where the moonlight rests upon the smooth surface. The water is so calm, that even a single leaf falling upon it, creates ripples that spread for miles. This is precisely what the wave function, the heart of the quantum world, is like. In 1926, Erwin Schrödinger wrote one of the most elegant yet bewildering equations in history, to explain the elusive movements of the subatomic world. This equation did not tell us where a particle was, it offered us a musical note, a map of possibilities of where that particle might be. Imagine this wave function, represented by the Greek letter psi. As a song, the universe hums to itself before making something real. While classical physics tells us, the electron is here. Schrödinger's equation says, the electron could be here, it could be there, and it is even more likely to be over here. This is the most aesthetic blow ever dealt to humanity's thousands of years of searching for certainty. Reality is no longer made of solid objects, but of constantly fluctuating, rising, and falling peaks of probability. We must stop imagining an electron as a tiny planet orbiting a nucleus. It is, in fact, a mystical cloud of mist surrounding the nucleus. A cloud of possibilities. Why is this wave function so important? Because it is the universe in its state of slumber. Until you make a measurement, the particle does not take on a single identity. It wanders through all those complex mathematical valleys and hills offered by Schrödinger's equation, simultaneously. This demonstrates the immense patience of the subatomic world. Everything, every potential, every possibility is kept alive within that equation. The wave function is the memory of the universe, it holds within it, like a tangled ball of yarn, all the paths a particle could have taken in the past, and all the points it could occupy in the future. Now, let us move toward perhaps the most radical and liberating law of the quantum world, Werner Heisenberg's uncertainty principle. In 1927, a young Heisenberg discovered that at the heart of the universe, there is a boundary that neither technology nor genius can ever cross. This boundary was not a deficiency, but a protective shield of nature itself. The principle is simple, yet its consequences are staggering. The more precisely you know where a particle is, the less you know about where it is going, and how fast. Or vice versa, the moment you measure its velocity exactly, you condemn its position to an infinite uncertainty. Nature is saying to us, you cannot have everything from me at the same time. This is like a privacy policy of the universe. Classical physicists did not love this. For them, information was always there, just waiting to be found. But Heisenberg proved that this uncertainty was not a flaw in our measuring tools, but a fundamental part of reality. The universe is inherently a bit blurry. And this blurriness is actually what allows everything to move, what allows life to flow. If the position and velocity of everything could be known at the same time, the universe would be like a frozen, lifeless, clunky clock whose fate was written seconds ago. Uncertainty is freedom. The fact that the exact location of an electron is unknown, allows it to dance through the universe. Thanks to the uncertainty principle, atoms do not collapse, the sun continues to shine, and miraculous events we call quantum tunneling occur. Use this law as a tool to relax your mind. Think of the moments in your life where you couldn't control everything, where you couldn't predict the outcome of every event. Those moments are your quantum nature. When even the universe does not know the position and velocity of its own particles at the same time, isn't our human desire to control everything quite exhausting? Now, I ask you to set aside all the rigid boundaries of your logic, and simply imagine. Think of holding a coin in your palm. When you toss it into the air, what is it to you while it spins between your fingers? Is it heads, or is it tails? The classical world tells us, while the coin is in the air. It is either heads or tails, you just don't know which one yet. But the quantum world, with its ancient and wise voice, whispers something much more startling. While the coin is in the air, it is both heads and tails. And not just that, it is every geometric possibility in between. This is superposition. It is a particle donning all identities, all locations, and all states offered by the universe simultaneously, until it is limited by a measurement. Try to feel the vastness of this concept. An electron does not just sit at one point around the nucleus, it exists at every point around the nucleus at the same time. It is not a particle, but a cloud of potential. This is the greatest generosity nature offers us. The universe walks all paths simultaneously before deciding on one. If the quantum world were not like this, atoms could not hold together, chemical bonds could not form. And we could not have evolved into these complex, magnificent life forms. Superposition is the immense creativity of the universe, within its indecision. As you lie in bed now, think of all those great maybes in your own life. The paths not taken, the cities not visited, the people not met. At the quantum level, each of these possibilities is still fresh, and continues to ripple somewhere. Superposition teaches us this: reality is not just what we see. What we see is only one of billions of possibilities, frozen into place. Every moment you are not looking, the universe returns to that vast sea of probability. As you fall asleep, your mind also enters a kind of superposition. In your dreams, you can be both here and there at the same time, living both the past and the future. Now, let us turn to perhaps the most famous, most talked about, and perhaps most misunderstood story in quantum physics, Schrödinger's cat. Erwin Schrödinger designed this experiment to show how absurd the concept of superposition could seem. However, over time, this experiment became the deepest philosophical question of quantum: where, in our minds, does reality begin? Imagine, there is a completely isolated box, invisible from the outside. Inside the box is a cat, a small amount of radioactive material, and a flask of poison gas that will break if the material decays. The decay of a radioactive atom is a purely quantum event, that is, within a certain period, that atom is in both a decayed and an undecayed state, a superposition. If the atom decays, the cat dies; if it doesn't, the cat lives. So, what is happening inside, until we open the box, and look? According to the cold and sharp logic of quantum physics, until we open the box, that atom has both decayed and not decayed. Therefore, that cat is also both dead and alive inside the box, at the very same time. This sounds like madness, doesn't it? How can a living being exist in two opposite states simultaneously? This is the mysterious bridge between the macro world and the micro world. Schrödinger gave this example to describe the massive shock that occurs when we apply the rules of the subatomic world to our world. But there is a much deeper, much more meditative side to this story. The cat, being both dead and alive, cries out the universe's need for an observer. When we open the box, that wave of probability collapses, and the cat is fixed into reality as either dead or alive. This is the final signature your gaze, your consciousness, signs upon the universe. Before you look, the universe is in a state of gentle indecision. It keeps everything alive, protects every possibility. Death and life, hot and cold. Existence and non-existence. These are just states until we open the box. Now, I ask you to push the very limits of your imagination and think of the two furthest points in the universe. On one side, the brightest star in the Milky Way, and on the other, a nameless, dark galaxy billions of light years away. Now, imagine that terrifying void between these two massive distances, a space that nothing, not even light, could ever cross in a human lifetime. Classical physics tells us that no information can travel faster than the speed of light. It would be impossible for something happening at one end to affect the other instantly. However, in 1935, quantum physics whispered a truth that kept Albert Einstein, Boris Podolsky, and Nathan Rosen awake: quantum entanglement. Entanglement is the sealing of two particles in such a way that they no longer act as two separate objects, but as a single entity, a single destiny. Imagine you have a pair of magic dice. You leave one here on Earth, and send the other to the far edge of the universe. When you roll the die here and it lands on a 6, the die billions of light years away must, at that very moment, without any delay, land on a 6 as well. There is no signal between them, no cable, no beam of light, only an instantaneous, absolute, and eerie harmony. Einstein called this spooky action at a distance, and found it very difficult to believe, because it destroyed our rule of locality, the idea that something can only affect its immediate surroundings. Feel yourself slowly sinking under the philosophical weight of this concept. It tells us that the universe is not actually made of separate parts, but that everything is connected by invisible, quantum-level threads. Perhaps since the Big Bang, because everything in the universe touched at one point. We are all still part of that massive entanglement. An electron in your body might be entangled with an atom in the Andromeda galaxy. A breath you take here might be causing a ripple at the other end of the cosmos. As you lie in bed, think of how this invisible web cradles you. You are never alone, no atom is ever truly solitary. What we call the void is actually a living fabric, where these entangled bonds vibrate. Deeply breathe in, and fill yourself with the peace of this cosmic unity. You are a key on the vast piano of the universe, and the echo of every note you strike is heard instantly in the furthest corners of infinity. Now, let us return to the most critical, most vital question of our quantum journey: when does reality become real? In previous chapters, we spoke of Schrödinger's elegant wave function, that sea of probabilities. A particle is everywhere, it is everything. It is a maybe until we look. But what changes when we look? Why does that vast array of possibilities suddenly shrink into a single solid fact, a single point, the moment we open our eyes? Physicists call this the collapse of the wave function. Visualize this collapse in your mind. Think of a massive, polyphonic orchestra where hundreds of different pieces are being played at once, blurring into one another. This is not a cacophony, but a mystical noise where all music exists potentially. However, The moment the conductor, the observer, raises their hand and points to a single note, those hundreds of pieces fall silent, and only one melody begins to rise. This is the art of extracting a single meaning from the immense noise of the universe. When we look, the universe decides. When we look, the maybes turn into nows. This situation leads us to think deeply about the role of consciousness in the cosmos. Some physicists argue that reality only collapses and solidifies when it is observed by a conscious being. This means that when you are not looking, the world loses that hard and defined form you are used to. The room behind you remains a mist of possibilities, until you turn your head. While this thought may seem absurd in daily life, it is a reality proven time and again in quantum laboratories. Reality is a secret agreement between you and the universe. You ask it a question, and it gives you an answer. For tonight, let everything be a wave again. Let all certainties melt away. You are simply the silent witness within this becoming. Now, I want you to imagine all the critical decisions you've made throughout your life, as a fork in the road. That street you turned down, that question you said yes to, or vice versa. Classical logic tells us that when you choose one path, the other vanishes, it is now only a memory, or a regret. However, one of the boldest and most provocative interpretations of quantum physics, the many worlds interpretation, offered us a different kind of comfort. No possibility ever vanishes. According to this theory, the wave function never truly collapses. Remember how the maybes turned into nows when the observer looked? The many worlds interpretation says that when the observer looks, the universe branches. In one universe, the cat is dead, but in another parallel universe created at that very moment, the cat is alive. Alongside the universe where you said no, another reality where you said yes. And lived all the consequences of that decision, continues to flow simultaneously, but in a different dimension. This means the universe splits into an infinite number of new universes, with every single quantum decision. Release your mind into the vastness of this thought. This means the universe is a massive library of probabilities. All the lives you could lead, all the people you could be, all the paths you could choose, are actually being lived somewhere. Between the layers of the quantum fabric. This is not a science fiction fantasy, it is one of the most consistent and startling solutions that quantum mathematics offers us. Superposition, being everywhere at once, applies not just to atoms, but to the entire universe. You are not just one person, you are the unique resonance of an infinite symphony of possibilities that you are listening to right now. We are now approaching the end of our journey. The great unification. All these crazinesses of quantum physics, entanglements, uncertainties, superpositions, eventually lead us to a single point. The purest, most naked state of matter. Physicists call this the Standard Model. It is the table of contents of the universe. Quarks, leptons, electrons, and those mysterious bosons, the building blocks of everything, but everything. But do not look at this model as just a list of particles. They are actually tiny knots on those massive, invisible energy fields upon which the universe is built. An electron is actually a vibration on an invisible sheet called the electron field that covers the entire universe. Just like a wave on the surface of the ocean. The wave passes by, but the ocean is there. You, I, the bed you lie on, and the air you breathe, we are all fluctuations of these fields. We are temporary, but magnificent patterns the universe creates within itself. Quantum physics has taught us that void is not actually empty. What we call absolute silence is actually filled with an endless dance of energy, with particles born and dying trillions of times a second. Now, one by one, release all those complex terms, equations, and theories from your mind. You no longer need to think about particles, waves, or Schrödinger's cat. Simply focus on your breath. Remember that the atoms making up that breath were cooked in the heart of a star billions of years ago. You are entangled with the beginning of the universe. You carry all possibilities within you. And you recreate this world every morning with your gaze. It is no longer time to learn, but time to be. Return to the sea of possibilities. Leave yourself to the safe arms of uncertainty. Everything is exactly as it should be, flowing within that immense quantum balance. From the sleepy scientist, good night.